Hello, so today we are going to do this problem, which is part of Leetcode daily challenge. Make array strictly increasing. So with this problem, we have two arrays. We have array 1 and we have array 2. And we want to return the minimum number of operations. It's possibly 0 that we need to make array 1 increasing. Okay. Now, how do we use this array 2? Well, what we need to do is choose. If we find an element in array 1 where it's out of order, it's not strictly increasing, what we can do is take an element, any element we want from array 2 that we haven't, of course, used yet, and not necessarily haven't used yet. It seems like we can use multiple times, but we can take an element from array 2 and use it in array 1, replace that element in array 1, so that we can get strictly increasing. Now, if it's not possible with any elements of array 2 to get the array to be strictly increasing, then we return -1. So let's look at an example that will make it easier. So here you can see if this is out of order. So what we can do is take this 2 from array 2 and replace 5 with it. Right, so put 2 here. That way we have 1, 2, 3, 6, 7. So we have an increasing a strictly increasing array now. Another example here, and what we want to return is the minimum number of operations. So here we only need to use 1, so we return it. It's not possible to use 0, and so the minimum is 1. Now here with this one, you can see 5 and 3 here are out of the order. So what we can do is take this 3 and replace this one here. But then the problem becomes that these two are equal, 3 and 3. And so we want to replace this 3 here with 4 from this position. That way we have 1, 3, 4, 6, 7, which is equal. Now if you can see if you can try multiple combinations, but it won't work because we can't use 1 here because then it will be equal to the previous one. We can't use 4 here because if you use it, then we can't get this 3 to be increasing. Because 4 is bigger, right? So that's why this is the best we can do, so we return 2. So that's the idea. Now if we look at the constraint here, we have up to 2000. Okay, so that tells us we could sort of try all possible combinations, but how can we be smart about it? Well, the first thing to note is that for array 2, you could if you have multiple elements with the same value, you can only use one of them because the array 1 has to be strictly increasing. So let's say, for example, in array 2, if we had maybe 3, 2, 3, 3, 3, 3 times 4, we can only use 1 3 because if we use 2 3s, that means in array 1 we would have 2 elements that are equal, but array 1 is strictly increasing, so we can't. And so the first thing we know is that we can remove duplicates from array 2. Now the other interesting concept is that it's sort of greedy concept, which is that for array 1, if we find a position that is out of place, it's always better to pick the smallest value from array 2 that will make it strictly increasing. It's always better to pick the smallest, right? So if we find a position out of place, it's always better to take smallest valid array 2 value. Okay, why is that? Because let's say, for example, let's take a look at this example with array 2 here, this one. For this 5, because it's out of order, because 5 is bigger than 3, what we did is we chose the smallest 3, because if we choose the biggest, which is 4, then we may end up in a position where we can't make the array strictly increasing, right? Because here, if we use 4, then now 4 is, then either we have to use 4 here or 3 or 1, but the problem is if we use 4, then these would be equal, so it's not strictly increasing. If we use 3, it's smaller, so it's not strictly increasing either, and 1 also smaller, right? And so it's always better to pick the smallest first that will satisfy the condition, because then we would have a better chance for the next one to use the greater value, the bigger value, right? Now, here we can't put 1 because it's equal. That's why I said here valid, the smallest valid one, okay? Now, how do we easily get the smallest valid one? Well, for a position, let's say here for 5, how do we do that? Well, for 5, what we want is we want the closest larger value to 3, okay? The closest value to 3. Because all that matters actually is the next element so that it's smaller than it, right? So we can choose to pick the closest value to the next one. Sorry, the closest value to the current one, to the previous one, right? So let's say we are here for this one. The previous one is 1. Okay, so we want to choose the smallest value that will be bigger than this one. How do we do that? Well, that's actually what bisect does, what binary search does. So what we can do is sort array 2, and now it should be easy to just bisect. We want the closest bigger value to the previous element, okay? So we want to bisect right. That's to get the closest to the right, closest bigger value. So if there isn't one element closer to 1, we want to get to the next one, not 1 itself. So we can bisect to array 2, in array 2, looking for, what we want to look for is the closest to the previous element, okay? And so this will find us 3. It won't find 1 because we want to the right, so it will find us 3. So once we get the index of this one, this is the one that we replace with. And so already this tells you that we need to keep track of prefix. And since we want to try all possibilities, as I said here, because the limit is small, what we can do is just have a function, let's call it DFS, because we'll explore everything, passing the index in array 1 and passing the previous value. Now this previous value can be either the previous element from the array 1 or the one that we just replaced the one element of array 1 with from array 2, right? So for example, in this case, let's do it. So in this case, first it starts out with the DFS from 0 to the previous element. Initially, let's just pick -1 because the array is guaranteed to be positive, right? The elements are guaranteed to be positive. So we just pick an element that is outside of the bound so that it's always smaller. It's for replacing, we actually, it's easier for us, instead of doing it only if this is smaller, if it's out of order, what we can do is just, for every case, for every element, just try to replace with an element of array 2. But pick the closest, right? Pick the closest. So what we can do here is just bisect, do this bisect here for the previous value so that we can find the smallest closer, the closer value to prev, and just replace it. So what do we mean by that? We don't actually need to replace it in the array. We can just pass it to the function, right? And just here, since we did the replacement, we did an operation here, and so we need to increment by 1. And so our count here would be, for each call, would be just need to be the min of these two, this one and this one, okay? And that's pretty much it with our recursive function. So let's just write out its skeleton here. So we need a DFS call at I, and we need to pass the previous value. So if we reach, base case is if we reach the end of array 1, okay? Then we want to return 0, no operations needed anymore. And now we need to do this call here. So we do our DFS, but we can't go to the next element using this one as prev if they are out of order. We can only do it if they are in order. However, we can replace and do an operation anytime. And so that's why we do it like this. But remember here, the prev now is the element from array 2, because this is what we replace the element at index I with. But instead of actually putting it in the array, we can just pass it as the previous value. That's all we need, because we only need the number of operations. But this is only if the element actually exists in array 2. If it doesn't exist, then we can't replace it with. So we have to check if it exists, which means smaller than the length of array 2. Then we can do this. And now we need to keep track of the min for the number of operations. So let's start out with a bigger value. Let's say take the min of the count here. So here we take the min like this. And here we want to also take the min of all possibilities here. And then we return that count. And now we want to call it with 0, and the prev initially is -1. But remember, we wanted to also remove duplicates and sort array 2. And so that's what we'll do. First, we remove duplicate by just getting a set and then getting the list out of that set. Then we sort array 2. And now we get a cost here, or let's call it count. And now we return that count, but we want to make sure that it's not, in case there was no solution, then this would be, right? In case this was false and this was false, then this would be infinity. And so that means it's not possible. So we want to return -1. So we check if count is different than this. Otherwise, it's different than infinity. Otherwise, we return -1 like this. So if we run this, it should work. It looks good. But we want to also cache, right? And so we want to cache the calls here. So you could use a hash with just these two as the keys. But in Python, I'll just do it quickly using a cache like this. So if I run it again, this will do the same thing as using a map. And so let's see if this works. Still time limit exceeded, so that means basically our cache limit was too small, so let's just make it bigger. Okay, looks good. Let's submit. Okay, so that passes. Yeah. So that's pretty much it with this problem. As an exercise, you can try to do it with just loops instead of recursion here. But that's pretty much it. Thanks for watching and see you on the next one. Bye.